In this video, we'll go over the various movement modes of your Link 6 robot. You can determine the current status of the robot by looking at the colored wrist LED indicator. Refer to the user guide for color mappings. As long as an enabling device is active, you can control the robot in manual mode using the buttons at the bottom right of the screen. Note that hand guiding can only be activated by pressing the wrist enabling device. In joint hand guiding, apply force on any joint of the robot to move it. In Cartesian hand guiding, force is measured by the force-torque sensor on the wrist. Constraints can be set to lock specific axes of translations or rotations. These axes can be defined in either the tool or base reference frame. The Link 6 can also be moved in jog angular mode, which allows for the angle of each joint to be increased or decreased. First, hold an enabling device to enable the jog angular interface. Then, click the arrows to move each joint individually. Click the small arrow on the top right to set the amplitude of the velocity commands sent when the arrows are pressed. You can also move in Cartesian mode, commanding the end effector to move side to side and up and down to change its orientation. Tap the arrows while pressing an enabling device to make the robot move. The small arrow on the top right allows you to set the amplitude of the velocity commands, or change the reference frame used for them if desired. Let's talk a little bit about singularities. You can put away the quantum mechanics books. Singularities in this context are positions that cause kinematic issues and prevent robot movement. Let's go through some examples. The first is a shoulder singularity. This happens when the first actuator has to move quickly from one side of the robot to the other, generally when going over itself. There are also wrist singularities. These occur when the end effector of the robot is perpendicular to the first actuator. Another is an elbow singularity. This is when the third actuator is close to its zero position. That is, when the bicep and forearm of the robot are almost aligned because the robot is reaching too far on the edge of its workspace. When the robot gets near a singularity, its speed can increase suddenly, which in some cases causes faults. Try not to stop the robot in a singularity while in Cartesian control mode. If the robot does stop moving due to a singularity, however, the fix is simple. Switch to angular control mode and move the robot away from the singular position.